Hello and welcome to another video. In this one, we're going to be talking about PEP 695, which is the brand new generic and type alias syntax that was introduced in Python 3.12. I actually talked about this in another video about all of the brand new things in Python 3.12, so I will link that in the description. But I made a mistake and I didn't completely go over all of the various ways that you can use the syntax, so this will be a more in-depth video on the brand new syntax. But anyway, let's jump into it. Okay, today we're going to be working in Python 3.12, so I need to set up a virtual env. Note we're using 3.12 since that's when all of this new syntax was introduced. Pip install mypy, so we get ourselves a type checker. Oh good, the internet's working this time. Second record. Okay, so, and my text editor is going to hate all of these because it hasn't implemented the new syntax yet, so there's no good grammar for this. But anyway, let's start with just some basic examples of how you would use both type variables and aliases today, and then we'll show how to transform all of those into the brand new syntax. Let's get started. Okay, so first for generics, I'm just going to make some type variables. So to do that today, you do from typing import type var, you would assign a type variable at whatever scope, and then you would write a function which will just make an extremely simple generic function. Where this is a generic function f, which takes in a parameter t and returns that same type back. So any type that you pass in here, you're going to get the same return value. That's a generic function. You can write a generic class as well. So if we make a class C, we need to import generic and type var. Generic t. This is a class which is generic on the type t, and let's just say we initialize it with x that is t, and make it a complete example, and then property def my x, which returns a t. This is an example of a generic class. The other thing that I wanted to show you is an alias. And aliases are just done through module assignments. At least the older ones are. So let's say we had, and this is a useless alias because float and int are the same thing. But you could have a alias like this, int float. This is just a raw assignment to a type. And then you can use this type later on. Then there was the type alias PEP that came along, and I always forget what it's called. So what I do when I want to look it up is Python 3 typing, and click on this first one here. Absolutely not using AI type alias. Oh, it is just called type alias. That makes sense. Okay. So type alias. I don't use type aliases very often, so that's why I don't remember this. So the better way to do this is to explicitly name it as a type alias. Number types 2 type alias equals int float. The reason that this was added was so that if you needed to put quotes around something, the type system can differentiate this from just being a string to being a explicit type alias. Okay, so that's all the old stuff. That's the stuff that exists already. Now we're going to jump into the new things that were added in Python 3.12. I'm going to start with these simple examples first. We'll jump into more complicated examples later and talk about each of those specifically. All right, so the first are the type aliases. These are probably the easiest ones to explain. Instead of having an assignment here, it just gets a magical type equals in front of it. So these are type aliases. We'll actually talk about this. When do I talk about this? Later. I'll talk about this later. But we'll talk about it now briefly. All parts of type aliases are lazily evaluated, which means you won't need any of this special quoting in here. You can use all sorts of forward references, you know, even if this were referencing C later on, although that's not exactly here. We'll make a class D. That's not generic, because otherwise it's an error to have generics without generic parameters for your type aliases, but we'll get to generic aliases later. But yeah, you can forward reference without needing quotes. You don't need to do any special magic there because these are all lazily evaluated. Now let's replace our function here. This syntax is, I find, a little bit gross, but it's what we got, unfortunately. And yeah, my text editor hates it because it doesn't know about this special syntax yet. So to specify a generic, oh, that should have been T. To specify a generic for a function, you use square brackets after the function name before the parameters, and then this type variable will be in scope for this function. Note that this introduces a new scoping rule here. This actually isn't present in Python at all before this. This is scoped specifically to the parameters and the function body. There's like a special PEP 695 scope that happens between the global scope here and this function scope here. And at the parameters. Previously, all of the values of parameters were module scoped, but now the types are not. It's a little bit funky. For classes, it's similar. You no longer inherit from generic. This will be implied by using this brand new generic syntax. And actually, I think you can just get away with this. You don't even need the parentheses anymore. And so this will make a type variable here. Note that these two type variables are different. And this is an intentional part of the PEP. Previously, they would share the same type variable, even though they were actually specialized in different places and potentially resulting in different types. Now it's explicit that this T is disparate from this T, and like there's no T here. This would be name error. And this is an intentional part of the PEP to make sure that type variables are very specific to the thing that they're making generic. So that's the basics of this PEP, is this new type. Square brackets for functions and classes to make them generic. And actually for type aliases as well, that same syntax is used. So you can do mylist equals list T. So this is a type alias from mylist to list, and so you would use it as like def g mylist int. It's bad. Whatever. And so this is how you would use this generic alias. This also isn't different than what you would have today. Instead of writing it like this, you would have mylist equals list T, and you would have T equals type var. So that's how the old version of this would go. So you can also make generic alias as well. Okay, so that's the basics of this, and now we're going to get into the more involved examples here. Where we're going to talk about things like variants, bounds, constraints, type var tuples, and param specs, since all of those are technically covered by the brand new syntax as well. Okay, so that's basic examples. Let's move on to this more complicated examples. And the way I'm going to write these is I'm going to write the old version, and then I'm going to edit it to the new version so that we get kind of the before and after. I'm also only going to be using functions here. The same applies to both classes and type aliases, but it's much easier for me to just demo with functions, so that's what we're going to do. All right, so the old syntax from typing import type var, we're going to start with bounds first. A bound in a type variable means that it must have the passed in values, or the passed in types that it's going to be specialized on must be subclasses of the particular type. So if we make a type var that has a bound, you specify this by doing bound equals, let's just say int. So this will say that all t's for this function must be a subclass of int. Now, you probably don't subclass int very often, but so it's kind of a silly example. But usually you would use bounds with like a protocol or some abstract base class or some class that is typically subclass. In this case, we're just doing silly examples, so they're going to be bound equals int, and we're going to use built-in types, so I don't have to make a bunch of stuff. Okay, so you would have a function like this, t, return t, sure. Something like this. That's the old way. The new way for this one is bounds are specified directly in the square brackets, and they are done so with a colon. And so a colon says that this is bounded by int, and so then the rest of it is the same. Yeah, again, my editor is going to be mad, but they'll just have to ignore it. So this is saying that this type variable t is bound by int. This is pretty familiar syntax if you've worked in other languages that have generics with bounds. I think Kotlin has this same idea. C# has this same idea. I think Java, it's extends. There might be extends in C#. I don't know, one of the two. It's been a while since I've written generic C# or Java, but okay, so that's bounds. Now let's go on to constraints. We'll actually just do that in another file. Yeah. Constraints, similar to this from typing import type var. Constraints is basically choices. So t equals type var. We could say that this has a choice of str or bytes. There's actually a built-in type variable that's often misused for this, but this is a type variable. There are only two t's that could be possible here. One is str, the other is bytes. And we'll just do the same. We'll actually do none because it's less typing. Technically this is invalid. You need to have it be part of your return value. So all right, we'll do the whole thing. Okay, so this is a function that takes either str or bytes and returns the same str and the same bytes. In the new syntax, this uses that same square brackets. And this is actually one of the few places in the syntax where we're actually going to use tuple literals. It uses sort of similar to the bound syntax, but it is not the same. And this is actually one of the things I screwed up in the my other video. But so this is saying that t is bound by str or bytes, or not bound, is constrained to str or bytes. So this can only be str or only be bytes. And so it's sort of templatized on those two types there. So that's how you do constraints. I don't think you can, actually, well, in the old syntax, you could call type var, but I think it was an error to have both bounds and constraints, and so they can fit the same slot here without having any problems. Also note that this tuple literal has to be inside of this type variable. It can't reference something outside. So if you made an assignment here, that's invalid according to the PEP. Okay, that's constraints. The next thing to talk about is variants. So variants I haven't explained very well. There's invariant, covariant, and contravariant, which are three ways that things can be assigned to each other or not assigned to each other. And I really need to make a whole video on it, but I'm just going to briefly go over it here. In the old type var syntax, you would specify whether it's variants directly in this. So you would say like u equals type var u covariant equals true, or invariant, or contravariant, etc. You would specify that directly as parameters in here. In the new syntax, there is no way to specify variants at all. But the good thing is the type checker is required to infer the variance. So it will check your, the entire scope where that type variable is around. And this is, again, one of those benefits of it being strictly scoped. It can check the whole scope and know whether it would be covariant, contravariant, or invariant automatically. So you don't have to specify it at all. It will just figure it out. And this is really great because figuring out the right variance for your type variables was always a big pain, especially if you forget how the rules work. Interestingly enough, this is actually backported to the old syntax, so you can use infer variance equals true, and this will tell the type checker that, hey, just figure it out for me. I don't want to think about variance. Just make it happen. It'll also produce errors if you use this incorrectly, which is nice as well. So yeah, nothing about variance. You don't have to worry about that in the new syntax. All right, next one is type var tuples, and I did a video on that as well, so I will link that in the description. The whole syntax for type var tuples goes away. So previously what we do is from typing import type var tuple. This is a way to represent a variable number of types. My example for this I don't think is actually correct, but I'm going to write it out none the same. This was copied roughly from the PEP, although I changed it and simplified it a little bit. Yeah, this is definitely not correct because it's based on a variance, but or based on a a type variable here, but none is referenced in other parameters or the return value. So yeah, this is definitely not a correct example, but just for the sake of the syntax, we're gonna go over this. Okay, so that's kind of what you would do. In the new syntax, a type variable or a type var tuple is represented by a starred type variable inside the syntax here. That is how you would reference this or create this here. So this makes a type var tuple similar to what we saw with other type variables here. Similarly to type var tuple, you would also get something for paramspec. We'll make another file for that. E5. I also did a video on paramspec as well. Import paramspec, p equals paramspec. And a param spec is useful for describing the parameters of usually a decorator or a wrapper function or a function that calls a function. And it gives you a way to decompose the star args and star quarks types of the original function so that they can be forwarded on. And let me look at my, oh god, this is quite an involved example here. So callable P9 to callable P9. FG impulse star args p dot args star quarks p dot quarks to none turn f. Yeah, this is a really involved example. Return g info. Yeah, so this is basically a decorator called g, which is a no-op decorator. It doesn't do anything here, but it's I actually return. This isn't quite right either, so we need t equals type. We'll call it R. Type var R. Yeah. That's what I get for writing down my example really quickly before this. Okay, so this is a function which takes in a callable that has a particular parameter spec and a particular return type and returns a new callable with the same shape. This is that new callable where it matches the args and quarks and returns the same value, and it just calls this. This is a trivial decorator. And you would probably, you know, functools.wraps f in here as well, but okay, so that's how you would write this in the old version with param spec and typevar. In the new version, it looks very similar. I'm actually just gonna copy and paste this because that makes this easier. Our return value is still specified just as R. Our param spec is double starred. Hope they don't invent a new syntax for something else that you would need, because we've run out of things to put into this square bracket here. But this, and you would get rid of these up here. I guess we'll just edit. That'll make it easier for the code samples on okay. R star P. And I think they have to be in this particular order. I'm not super sure. The type checkers haven't really caught up to this yet. Well, Pirate has, but I don't know that MyPy has. Let's see, MyPy. Let's see what MyPy says here. P is not defined. Yeah, 695 is not implemented yet. So, oh, and I forgot to mark call but yeah, not implemented yet. But this is what it'll look like there. And so that's param specs. Okay. So now we need to get to the other wrap-ups here, which is that param specs, or sorry, PEP 695 type parameters and aliases are always lazily evaluated. That means both their type definitions as well as anything they're aliasing or any of their bounds. None of that needs to be quoted anymore. There's a special lookup routine that makes them look up when they're accessed. So this means that you technically don't even need from future import annotations for those, because they will just be lazy all the time. There are two major incompatibilities with 695 and previous code, so I'm going to call those out explicitly. I actually kind of called out one of them already, which is that these don't introduce names anymore. So if you were sharing a type variable or importing a type variable, you can't do that anymore. They're not accessible, they're not shareable, and this is intentional. One for that variance thing that I talked about before, but also because it was very confusing which T referenced what T, and you got T's in 50 files, and sometimes they're imported, sometimes they're not. This makes it explicit that this is locally scoped to this particular function or this particular class here. And so you can't import them, you can't reuse them. The other one, and I think this one is an oversight, these type aliases here. So let's say we take this and we open up Python. An old or a new type alias here, and an old one, old number types equals int float, works slightly differently. With the old aliases, you could use them inside of isInstance, and so you get true and false here. The new type aliases are not allowed inside isInstance. They produce an error. So before you go running a code mod to replace all your old type aliases with new type aliases, you gotta make sure that they're not actually used anywhere except at typing time. And this is a big pain in the butt. I was hoping to automate this, but can't do it because they're not the same. But that's gonna wrap us up. That's all of PEP 695. Well, there's probably other tidbits that I left out, but that's most of the stuff you need to care about. Hopefully you found this interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.